Hello students, this is AMOL INGOLE. In this video, I'm going to explain why this name convolution encoder is given to this encoder. That means we're going to discuss the convolution point of view in this encoding. So let us begin. The encoder outputs of the convolution encoder are formed by modulo 2 discrete convolution. This is the reason why that name is given as convolution encoder. It is because the outputs of the encoder are formed by modulo 2 discrete convolutions. That means if a certain convolution encoder is having two outputs, V1 and V2, this output V1 can be obtained by convolving the input bit stream U with the generator sequence G1. So by convolving the input bit stream with the generator sequence G1, you can obtain output V1. Similarly, output V2 of the encoder can be obtained by convolving input bit stream U with generator sequence G2. And the final output can be obtained, encoder output can be obtained using this equation. So you have to just consider one bit each from V1 and V2. So first bit of V1, that is V10. After that, first bit of V2, that is V20. Then second bit of V1, that is V11. Then second bit of V2, that is V21, and so on. If you write it like this, you get the encoded output for the encoder. To understand this properly, we'll see one numerical on convolution encoder using modulo 2 discrete convolution. So let us consider this example where the input bit stream is given as 10111 and the generator sequences are given as G1, which is 1011, and G2, which is 1111. Determine the encoded output using modulo 2 discrete convolution. So we are going to use modulo 2 discrete convolutions to find the output of this encoder. So let us see. From the statement, you can first identify these things. The length of the input bit stream is 5 bits. This U has got 5 bits in it. So the length of the input bit stream, we are calling that as X, is 5. The length of the output bit stream can be obtained using this equation, which is X plus M, where M stands for number of memory units. You can see here in the generator sequence, it has got 4 bits. That means length of the memory unit will be 1 less. So 4 minus 1, that is 3. So it will have 3 memory units. So M will be 3. And N is 2 in this case. Why? Because there are 2 generator sequences given. That means there will be 2 outputs. So N will be 2. So that 2 into X is 5 and M is 3. So 5 plus 3, that is 8 into 2. So there will be 16 bits in the output. Let us see how we can get the output of the encoder. You need to find out output V1 and V2. Why 2 outputs? Because N is equal to 2. Because there are 2 generator sequences given. So you need to find out V1 and V2. Let us see how V1 can be obtained. So as the name convolution encoder given, you need to perform modulo 2 discrete convolution on the input bit stream with the generator sequence. So by convolving the input bit stream U with the generator sequence G1, you can get output V1. Perform the modulo 2 discrete convolution and you can see that the output V1 can be obtained like this. Similarly, you can find output V2 by convolving the input bit stream U with the generator sequence G2. This is the input bit stream with the generator sequence G2, which has got all ones. By convolving these, you will get output V2. And the combined output of the encoder can be written like this. First bit of the encoder, that is 1 V1, and first bit of the V2. So 1 1 will be the first two bits. Then V11 and V21, that means second bit of V1, second bit of V2. So 0 1 will be the next two bits. You can write it here. 1 1. So it comes from 1 1. Then next two bit will be 0 1. You can see here. Next two bit will be 0 0. You can see this here. Next two bit will be 0 and 1 0 1 and so on. That's how the combined output can be written. Let us see how actually you can perform this modulo 2 discrete convolution with example. So we'll take the same input bit stream. You need to prepare a table like this to find output V1 using modulo 2 discrete convolution. So prepare a table. Here this is the input bit stream and this is the generator sequence G1. You need to perform the modulo 2 multiplication on this first. So multiplying the entire input bit sequence with 1, you get the same thing. Anything multiplied with 1 will be the same. So 1 0 1 1 will remain same. Then multiplying 0 with the input bit stream, you get all zeros. That means anything multiplied with 0 will get you 0. Again, multiplying this 1 with the input bit stream, that is 1 1, will get you the same input bit stream and so on. Now you can write output V1, which is obtained by convolving the input bit stream with G1. This can be written like this by XORing diagonally. So the first bit will come from this and it is 1. The second bit of the output V1 can be obtained by XORing these two bits diagonally 0 0. So XORing 0 with 0 will get you 0. The third bit of V1 can be obtained by XORing these three bits. So 1 XORed with 0, XORed with 1, you get 0. 1 plus 1, 0. Next bit, that is fourth bit of the V1, can be obtained by XORing these four bits 1 0 0 1. By XORing these four, you get the fourth bit. Next bit, that is fifth bit, can be obtained by XORing these. So diagonally, you're supposed to XOR the bits and write the output bit V1 like this. That's how you will get V1 and having these many number of bits. Similarly, you can write the output V2. You need to prepare a similar table. This is the input bit stream and here generator sequence G2. Again, you have to first multiply this. So as it has got generator sequence with all ones, you multiply it with the input bit stream, you get the same thing. So all rows will be same. V2 can be written, which is obtained by convolving the input bit stream with generator sequence G2 by performing the XORing operation diagonally. So this is the first bit. Second bit of V2 can be obtained by XORing diagonally these two bits 1 0. So 1 0 XOR will be 1. The third bit can be obtained by XORing 1 0 1. So 1 plus 1 is 0. Fourth bit can be obtained by XORing 1 0 1 1. So 1 plus 1 0 plus 1 1. So this is how you can write all the remaining bits of output V2. Once you get V1 and V2 using this technique, you can now write the combined output V of the encoder by taking one bit at a time from V1 and V2 simultaneously. So the first two bits will be 1 1. That's how you can write the output of the encoder. Thank you.